Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in mathematics, we were discussing the very first chapter, that is number systems. Now, let us go for continuing this. Before that, just we shall recall some of the important points what we discussed. The very first point, we come across different types of numbers. Second point, we learned how to find out rational numbers between given two given rational numbers. The third point, we learned how to locate irrational numbers on the number line, like the numbers root 2, root 3, root 5, root 10 and so on. Here we followed the three methods. The very first one is spiral method, second one is vertical method and third one is horizontal method, particularly for some numbers like root 5, root 10, root 17, root 26. After that, we define the rational number in terms of decimal as a number whose decimal expansion is terminating or non-terminating recurring is called a rational number. Based on that, we took some examples for decimal numbers, and using that we classified the decimal numbers into different types. The very first one is terminating, second one is non-terminating. In non-terminating, again recurring and non-recurring. Then in recurring, pure and mixed. Got it? So these are the different types of decimals. And among these, one of the important problem is locating root 5 on the number line by spiral method. In the last class, I had already taught. Once I go for teaching you clearly, please observe this. So you have to follow this method to locate root 5 on the number line. Here I'll write locate root 5 on the number line. Now I go for taking a scale, then draw a straight line and go for marking for every 2 centimeter. Here 2 centimeter, 2 centimeter, 2 centimeter, as it is root 5. So you need to extend the line. Again I go for marking for every 2 centimeter. Here 2 and here 2. Next, let us show the arrow mark on either side. So this is, I take this point as 0, this point as -1. That is left side of 0 or negative, right side of 0 or positive. This is 1, this is 2, this is 3 and this point is 4. Let me take the point which represents 0 as A. Another point 1 which represent this as B. Now take a protractor, then place the midpoint of the protractor at B and mark against 90 degree. So then draw a perpendicular line. Now it is perpendicular, show the right angle. What is the length of AB? Here we have taken this as 1 unit. So you can write that in the scale. Scale is, here we have taken 1 unit as 2 centimeter. Next, you have to use the compasses. Take the distance AB. Then in compasses, with B as center, draw an arc which cuts the perpendicular at a point. Call this point as C. Now join CA. Then what is the distance of BC? It is also 1 unit. What is the distance of AC or length of AC? It is root 2. Already we have calculated. Now next, take protractor and place its midpoint at C. Mark against 90 degree. Take a scale and draw a line from C through the point marked. Next, take the compasses, again the unit distance with C as center, draw an arc. So this is point D. What is the length of CD? It is also 1 unit. Then join DA. What is the length of AD? It is root 3. Even we have come to know how to calculate the length of AD. Next, again you should take the protractor, place its midpoint at D, mark against 90 degree. Then take a scale, draw a line from the point D and let it pass through the point marked. In compasses, again take 1 unit, that is distance of AB, with the D as center, draw an arc. Here I am showing that. This is point E. What is the length of DE? It is 1 unit. Next, take a scale, draw the line and join EA. What is this? It is root 4. But we have to locate root 5 on the number line. Hence, again it should be continued. Place the midpoint of the protractor at E, mark against 90 degree. Then draw a line from E, let it pass through this marked point. Take the unit distance AB with E as center, draw an arc which cuts the perpendicular at F. Then join FA. Now, what is the distance of FE? It is 1 unit. See, here CD, DE and EF all are perpendicular. Without fail, we have to show a right angle symbol. Now, what is the length of AF? We do not know that. So, we can go for calculating by using Pythagoras theorem. Here, in triangle, you have to take the last triangle AEF. Angle AEF equal to 90 degree. By Pythagoras property, so you can write square on hypotenuse, that is AF square is equal to sum of squares of other two sides. Other two sides are AE and FE. So I will write AE square plus FE square. What is AE? AE is root 4 whole square plus FE, it is 1 unit, 1 square. Square and root get cancelled. This is 4. 1 square is 1. This is 5. So AF equal to root 5. Now you can mark here root 5. This is the length of AF. But it should be represented on the number line. Hence, I go for taking the distance of AF using the compasses. Okay, AF should be taken like this. Then draw an arc. Draw an arc and it cuts the number line at a point. I call this point is root 5 because the length of AF and the length from A to this point is equal. So I just go for drawing the arc. See. So this is how we have to locate root 5 on the number line. Clear? So one of the important problem to be asked in the examination, locating root 5 on the number line by spiral method. Okay, now just we shall come back to the another part of this chapter, that is decimal numbers. Under the heading decimals of rational numbers. Right beside it. Decimals of rational numbers. Or simply you can write just rationals. Dear students, rational number can be defined in terms of decimal as a number whose decimal expansion is terminating or non-terminating recurring. To tell the decimal expansion of a rational number is terminating or non-terminating, is there any conditions? Yes, there are conditions. Now let us go for knowing that condition. Dear students, just go through this. Decimals of rationals. In rational number can be expressed in decimal in two forms. One is terminating and second one is non-terminating recurring. Then we are going to know the conditions to say whether it is terminating or non-terminating recurring. Here I have taken some of the example. Just observe here. In the first example, I have taken 7 by 8. Let us divide 7 by 8. 7 is not divisible by 8. Put decimal and take 0. 70 is there. 8s are 64. How much you will get? You will get 6. Then take 0. How much? 8 7s are 56. 4 will remain. Again take 0. Then 8. How much are 40? 5s are 40. So observing remainder is 0. Then what is the decimal expansion of 7 by 8? It is 0.875. Now, what type of decimal expansion it is? It is here countable number of digits in the decimal part. Therefore, it is a terminating decimal expansion. Now, let us take one more. 112 by 25. Let us go for dividing this. 112 by 25. 25 how much are? You can take 4s are 100. You get 12. Then put decimal, take 0. 25 how much are? Again 4s are 100. 0, then 2. It will be 20. 20. Then further it is not possible. Take 0. Then 25 how much are? 25. 8s are 200. Here also the remainder is 0. What is the decimal expansion of 112 by 25? It is 4.48. Now, just observe it. Observe it. 4.48. Even this is also a terminating decimal expansion because countable number of digits. So one thing you can conclude, if the rational number has terminating decimal expansion, what will be the remainder? Remainder will be 0. Got it? So now we can write the condition. Remainder becomes 0. Then is there any other condition? Let me tell you that after going through second case. Look here. Here also I have taken the example 1 by 3. Let us go for dividing 1 by 3. 1 is not divisible by 3. Put decimal, take 0. It becomes 10. Now 3 3s are 9. Difference is 1. Take 0. Again 3 3s are 9. Then 1. Take 0. 3 3 3 3 and it continues. Now I can write 1 by 3 as 0.333 and so on. Now what type of decimal expansion it is? It is non-terminating. In non-terminating only what type? Here some digits are being repeated. Therefore you can say that it is non-terminating recurring. Now let us divide 22 by 7. on dividing this, 7 3s are 21, 1 will remain, put decimal, take 0, 7 ones are 7, 3 will remain, take 0, 7 4s are 28, 2 will remain, again take 0, 7 2s are 14, 6 will remain, it is 60. Now 7 8s are 56, then 4 will remain 40, 7 5s are 35, 5 will remain 50, 7 7s are 49, 1 will remain 10, 7 1s are 7, 3 will remain, it is 30, 7 4s are 28, 2 will remain, and it is continued. Look here, here 22 by 7, its value can be written as 3.142857, again 142857, and so on. Then this can also be written as 3.142857 bar. So for repeating block, it is represented with bar. So here, in both the cases, the decimal expansions are non-terminating, recurring. But what I have observed, the remainder what we have got? Is it equal to 0? No. 10 is not equal to 0. 2 is not equal to 0. So if the decimal expansion of a rational number is non-terminating, recurring, then the remainder never becomes 0. This is second condition. Remainder never becomes 0. As I said, is there any other conditions? Let me tell you that. Let me write them as point. If remainder is equal to 0, then what it is? Then it is terminating. Another important point you have to consider, okay, here 7 by 8 is there. In the denominator, 8 is there. What is the factorization of 8? 8 can be written as, just observe here, 2 4s are 2 2s are. 8 is equal to 2 raised to the power 3. Then 25 is there. Divide, here also find out the factorization. 5 5s are. So 25 can be written as 5 raised to the power 2. In rational number, in p by q, whatever the denominator is there, that is q. If this denominator is either of the form 2 raised to the power n, or of the form 5 raised to the power n, or 2 raised to the power n into 5 raised to the power n, then we can say that it is terminating. Clear? I'll write this point. In p by q, if q is of the form 2 raised to the power m into 5 raised to the power n, it means it may be only 2 raised to the power n, only 5 raised to the power n, or 2 raised to the power m into 5 raised to the power n, then it is terminating. I hope that you all have understood this. Now, come across this. Here, remainder is not equal to 0. If r is not equal to 0, then we can say that in case of rational numbers, if remainder does not become 0, then it is non-terminating, recurring. If r is not equal to 0, then it is non-terminating, recurring. Now, and one more condition, you just observe the denominator terms of these rational numbers. Here 3 is there. Is it of the form 2 raised to the power m into 5 raised to the power n? No. 7, that is also not. Hence, we can say that in p by q, if q is not of the form 2 raised to the power m into 5 raised to the power n, then it is non-terminating, recurring. Non-terminating, recurring decimal expansion. I hope that you all have understood this. So now you have to pause the video and copy from here to there. Yes, copy that. Dear students, now we will move on to taking some problems which are solved in your NCERT textbook. So under the heading worked examples, just we have come to know there are two types of decimal expansions with respect to rational numbers. The first one is it is terminating. Second one is non-terminating recurring. Then how, if these decimal expansions are given, let us come to know how to express them in the form of P by Q, where P and Q are integers and Q is not equal to 0. Now let me go for taking the very first example. It is 5.127. Now could you tell what type of decimal expansion? Yes, your answer is right. It is terminating. Why it is terminating? Because it has countable number of digits in the decimal part. Let us come to know how to write it in P by Q form. 5.125 can be written as, see that, 5125. See, after decimal 3 digits are there, we can go for writing 1000. Clear? If 1 digit is there, then 10, that is 10. 2 digits are there, 100. Here 3 digits are there, hence it is 1000, which you have already learnt in 6th standard only. Now this is equal to, it can be simplified because both are divisible by 5. Now 5, how much are? 5 2s are, then zeros are zeros. Then 5 1s are, zeros are, 1 will remain, it is 12. 5 2s are 10, 2 will remain 25. 5 5s are. Again, it is divisible by 5. Now 5 4s are 20, 5 and zeros are. Next 5 2s are 10. Here 2 is there, not divisible, so that you can take 0. 5 20s are 100, 2 will remain 25, 5 5s are. Next, again it is divisible by 5. 5 8s are 40, 5 4s are, then 1s are, 41 by 8. So this is the P by Q form of 5.127. 5.127 is equal to 41 by 8. Now I will go for taking one more example. This is also simple example. It is 3.125. How do you write this? Very simple. It is 3.125 can be written as in the same way. 3125 divided by, after decimal we have 3 digits. I'll go for taking 1000. Again both are divisible by 5. Divide them by 5. 5 2s are, zeros are, zeros are. Here 5 6 are 30, 1 will remain 12, 5 2s are 10, then 2 will remain 25, 5 5s are. Then again 5 4s are 20, zeros are. 5 1s are, 1 will remain 12, 5 2s are, 2 will remain 25, 5 5s are. Then 5 8s are, 5 8s are 40, then 5 2s are 10, 2 will remain 25, 5 5s are. So 25 by 8. So 3.125, it is a terminating decimal expansion. Its P by Q form is 25 by 8. See that it is of the form P by Q, where P and Q are integers. These two are integers. Clear? Now, if non-terminating recurring decimals are given, how to express them in the form of P by Q? Now, let me tell you one after the other. Okay. Third one. Just observe this one. First one. Actually, it is 5.127. Here we have written 5.125. So just please change it. It is 5.125. Then this calculation will be correct. Okay. Now, this part third problem what I am going to solve is very important in the examination point of view. No doubt, one question will be given in the examination. You have to write the non-terminating recurring decimal expansion in the form of P by Q. Again, I go for taking the textbook example. It is 0.3333 and so on. See that it is a non-terminating recurring. There is no end at all and the digit is being repeated. Let us come to know how to express that in the form of P by Q. Here 0.3333 and so on, it is equal to here 0 point repeating block, let us represent it with 3 bar because only one digit is being repeated. Now let us come to know that. Let us assume the given number as x, that x equal to 0.3333 and so on. You may call it as equation 1. Now could you tell how many digits are being repeated? Only one digit, that is 3. 3 is being repeated. Hence we can go for multiplying both sides by 10. Multiply 10 on both the sides. Then 10 into x, it will be 10x. Then 10 into this number, that is 10 into 0.3333 and so on. See the 10 is there. When you multiply 10, you have to put decimal after 3. 3.333 and so on. If it is multiplied by 100 after 2 digits, that is after 33, like this. It is 3.3333 and so on. You may call it as statement, so equation 2. Now subtract equation 1 in 2. Now I'll write that x equal to 0.3333 and so on. Again I'll write it, equation 1. Let us go for subtracting this. Now subtract on the left hand side. 10x minus 1x, it is 9x. Now here, see the 3 get cancelled, 3 get cancelled. Now 3 minus 0, it is 3. Now solve x equal to 3 by 9. On cancelling you will get 1 by 3. What is x? Where x is 0. Here I have written 0.333 and so on. This is equal to 1 by 3. This is the method of expressing non-terminating recurring decimal in the form of P by Q. Clear up? You have to practice this, very important in the examination point of view. Now I go for taking another one, and this is also very important. It is 1.27 bar. Here I will write it that. It is fourth problem. Fourth one is 1.272727 and so on. The examination, the question can be asked like this. Express this number in the form of P by Q, where P and Q are integers and Q is not equal to 0. Now, here I will write 1.272727 and so on. It can be written as 1.27 bar because two digits are being repeated. Now, let us take x. You may take x, y, z, whatever the letter you want. Let x equal to 1.272727 and so on. You may call this as equation 1. Now, can you tell what should be multiplied on both the sides? Yes, your guessing is right. Your answer is right. It is 100. Why it is 100? Because two digits are being repeated. As I said, if one digit is being repeated, 10 should be multiplied. Two digits, 100. Three digits, 1000. Like this. Now, it is multiply 10 on both the sides. So now 10 into x, 10x, sorry, 100 on both the sides. 100 into x, 100x. This is equal to, multiply 100. If you multiply 100, what I said? So you have to put the decimal after 2 digits. 2 digits are 27. Now it will be 127 point. Now remaining 27, 27, 27 and so on. I call it as equation 2. Subtract equation 1 in 2. Equation 1 is x equal to 1 point. Very important. Whole number part and decimal part. 1.2727 and so on. Call it as equation 1. The same thing has been written here. Now on subtracting 100x minus 1x, how much it is? It is 99x. Now here 7 7 get cancelled, 2 2 get cancelled, 7 7 2 2. Now 7 minus 1 is 6. 2 as it is 1 as it is. 126. Now we can write this as solve x equal to 126 by 99. So both are divisible by which number? 3. See, 9 and 9, 18 is the multiple of 3. 1, 2, 6. 1 plus 2, 3. 3 plus 6, 12. Sorry, 3 plus 6, 9. 9 is the multiple of again 3. Cancel it by 3. 3 3s are 3 3s are 3 4s are 3 2s are. Next, it is equal to, here I'll write, this is equal to, again both are divisible by 3. 3 1s are 3 1s are. Next 3 1s are, 1 will remain 12. 3 4s are 14 by 11. So this is the P by Q form of 1.27 bar. 1, therefore we can write 1.27 bar or 272727 and so on is equal to 14 by 11. I hope that you have understood. And by observing these two examples, you can go for expressing them in a very simple way. I'll tell you that. See that both are started with 0, 0.333 and so on. 0.3, it is 3 by 9. Here 1.27 is there. Now 1.27 is 14 by 11. Let me tell you how to write this in another form. Just observe here. Here 1.27 bar is there. Now this is equal to, this can be written as 1 plus 0.27 bar, right? Yes. Now this is equal to 1 plus 0.27 bar. Earlier we learned if 0.3 bar is there, it is 3 by 9. Here now 0.27 bar is there, it is 27 by 99. So here I'll write 27 by 99. Now cancel them. 1 plus, here 9. 9 ones are, 9 ones are. 9 how much are? 9 threes are. Now take LCM, 11. Now multiply 11 with first term. 11 ones are 11. Multiply 11, that LCM with the second term. 11 get cancelled, 3. 11 plus 3, it is 14. 14 by 11. Same thing. 1.27. Got it? So this will be easier method for pure decimal expansions. Now I go for taking one more example. So before that, you have to pause the video and should copy up to here. Now let me go for taking another problem that is also very simple one, as being given in the textbook, and also it was given in the examination as well. It is fourth one. The number is 0.001 bar. Bar is applicable to all the 3 digits. Now let us come to know how to express this in the form of P by Q. Here I write, let x equal to 0.001 0, 0, 0, 1 bar is there. As I said, here the repeating block is 0, 0, 1. Here I write 0, 0, 1, 0, 0, 1 and so on. You may call it as equation 1. Then could you tell what should be multiplied? Yes. Here how many digits are repeated? 3 digits are being repeated continuously. Hence we have to multiply 1000 on both the sides. Then it will be 1000x is equal to, here multiply 1000. 1000 means after 3 digits. It will be 1.001001 and so on. Call it as equation 2. Subtract equation 1 into, then x equal to 0.001, 001 and so on. Now put minus sign for subtracting. 1000x minus 1x, how much? 999x. Now here 0, 0, 0, 0, 0 and so on. It is 1. Now we can write x equal to 1 by 999. Hence we can write 0.001 bar is equal to 1 by 999. Got it? Very simple way of expressing. Now, if it is so, just for the sake of testing your understanding, I'll ask you few questions. Suppose 0.7 bar is there. How do you write? How do you write it directly? It is 7 by 9 because only one digit is repeated. Next, 0.23 bar is there. How do you write? It is 23 by 99 because 2 digits are repeated. If 0.123 bar is there, then we can write it as 123 by 999 because 3 digits are there. Clear? Still it can be simplified. This is the method you have to remember. Now we will move on to solving some more problem. Before that, again you have to pause the video and write from here to here. Copy that. Okay, dear students, I go for taking one more problem, but it is mixed decimal number or mixed decimal expansion, which is non-terminating recurrent. Observe. Fifth one is, it is 0.235 bar. So bar is applicable only for 3 and 5. Let us come to know how to express this in the form of P by Q. Observe, don't copy. Here, let us take x equal to 0.235 bar is there. Repeating block is 35, 35, 35, 35 and so on. You may call it as equation 1. Could you tell what should be multiplied to both the sides? Yes, it is 100. Why it is 100? Because in the repeating block 2 digits are there. Here I will write multiply 100 to both the sides. Then it will be 100x. Here on multiplying 100, the decimal comes after 23. So 23.5353 and so on. I call it as equation 2. Subtract equation 1 in equation 2. That is x equal to 0.235353 and so on. It is 1. Now as we are subtracting, just writing here minus sign. What is 100x minus 1x? It is 99x. Now subtract here. Here 3 minus 3, 0, 5 minus 5, 0, 3 minus 3, 0, 5 minus 2, it is 3. Now here 23 as it is, because 23 minus 0 is 23 only. Now 99x equal to 23.3 can be written as, it is 233 by 10, because after decimal we have one digit. Now cross multiply. X equal to 233 divided by 99. Tens are 990. Clear? So x equal to 233 by 990. Therefore, the given number 0.235 bar is equal to 233 by 990. This is the method of expressing mixed decimal in the form of P by Q. Now, I go for taking one more example from the NCERT text only. Don't copy. Afterwards, I will give you time for copying. It is like this: 0.47 bar. Here, bar is applicable to only 7. Now, let us go for expressing this in the form of P by Q. Now, it is, this time I go for changing the variable. I take y. Let y equal to 0. Should we write 474747 so on? No. Then what should be written? Yes, 477777 so on. Call it as 1. How many digits are repeated? Only one digit is repeated. What should be multiplied? Yes, 10 should be multiplied. Multiply 10 to both the sides. Next, it will be 10y. It's equal to, on multiplying 10, it becomes 4.7777 and so on. Call it as equation 2. Subtract equation 1 into, then y is equal to 0.477 and so on. Now, on subtracting, minus 10y minus 1y is 9y. Here, get 7 get cancelled, 7 get cancelled, 7 minus 4, 3, 4 minus 0, 4, 44.3. Clear? Now, you can write like this: 9y is equal to 4.3 is there. It can be written as 43 by 10, right? Then y is equal to 43 by 9 into 10. It is 90. Understood? Therefore, what is y? Y is 0.47 bar is equal to 43 by 90. And you can also write like this: y, 9y equal to 4.3. Y is equal to 4.3 by 9. After decimal, one digit is there. You can write 43 by 9 directly. This way also. Clear? Now, you have to pause the video and should write from here up to here. Copy this. Dear students, I hope that you have copied that, and just we have learned how to express the given decimal expansion, maybe terminating or non-terminating, recurring in the form of P by Q, where P and Q are integers and Q is not equal to 0. So these problems are very important. Definitely one will be asked in the examination. Now, here I have written some of the numbers. You are able to identify them. See, this is the number. Can it be expressed in the form of P by Q under the condition P and Q are integers? No. Then what type of number it is? Already we have learned that it is an irrational number. But can we define irrational number in terms of decimal expansion? Of course. How? Look here. Here, what type of decimal expansion are these two? First, to take for our first one, it is non-terminating. There is no end at all. There is no end, hence it is non-terminating. And whether any block is repeating, maybe consisting of 1 digit, 2 digits, 3 digits, no block is repeating. Then it is, can we say that it is non-terminating, non-recurring? Yes. And observe, here I have we have written the value of pi. It is 3.141592653589 and so on. It is also non-terminating, non-recurring. So such numbers are called irrational numbers. A number whose decimal expansion is non-terminating, non-recurring is called an irrational number. Please write the side heading, write with me. Irrational number. Irrational number. And irrational number is denoted by the symbol Q dash. Let me write the definition, write with me. A number whose decimal expansion is non-terminating, non-recurring. Non-terminating, non-recurring is called an irrational number. An irrational number. And the example, you may go for copying this root 2 value, this is, and pi value, this is. Okay. Now we all know that many times we take the value of pi as 22/7. No, it is not equal to 22/7. For the sake of calculation only we take pi as 22/7. But actual value it is being calculated. Do you know the first mathematician who thought of giving value of pi? Yes, he is Archimedes, and he has given the information that the value of pi lies between, look here, 3.140845 and 3.142857. This information was given by Archimedes. Archimedes value for pi. It should be written. Next, another Indian mathematician who has given the value of pi up to 4 decimal places, that is pi equal to 3.1416. Got it? So now it was given by Indian mathematician, he is Aryabhatta. Aryabhatta value for pi. And whatever the present computers and all there, using the high-speed computer also, we have found out the value of pi. The value of pi has the decimal in that more than 1.24 trillion decimal places are there. 1.24 trillion. Trillion means 10 raised to the power 12. So then high speed computers, high speed or advanced computer, high speed computers value for pi. Written up. Okay. Dear students, listen to me carefully. In the beginning of this chapter, we have learned how to write a rational number between two rational numbers. Now, let us come to know how to write an irrational number between rational numbers. Clear? But to write the irrational number, we have to follow one particular pattern. Just it will be easier to write. Now I am going to teach you that. Just keep observing. Suppose 0.15 is there. It is terminating. But we want non-terminating recurring. Sorry, non-terminating, non-recurring. See 150, 1500, 15, 3 times 0, 15, 4 times 0 and so on. Will there be any repetition? No. Is there a repetition of, do you say that it is the repetition of 150, 150, 150? No. See that here is 150, here is 1500, here 15,000, like that. So it is non-terminating, non-recurring. Now let us go for taking some of the examples that are given in the textbook. Yes, right. Here, observe the first one. Find any three irrationals between the first one, 2 and 3. 2 and 3 are rationals. We have to write irrationals between these two. So now, can we write 2 as 2.0 and 3 as 3.0? Yes. Between them so many are there. It may be 2.1, 2.2, 2.3 like that. Many are there. I go for taking 2.15. 2.15 lies between 2 and 3. Did you understand? Here I'll write. See that. This is 2 and this is 3. Many points will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See 2.1, 2.2, 2.3, 2.4, 2.5, 2.6 and so on. Many are there. You may go for taking any one of these. It is 2.1. You may take 2.12, 2.13, 2.15 like that. 2.15. But it is terminating. We want irrational number. Irrational number is non-terminating recurring. Hence I can write it as 2.150, 1500, 153 times 0 and so on. Clear? Next. Again I will go for taking 2.23, 231, 23, 11, 23, 111 and so on. Next. You may go for taking 2.7, 72, 7, 22, 7, 222 and so on. See that like that plenty of irrationals can be written between these two rationals. Now let us move on to another example. Don't copy, just keep observing. Afterwards you can copy by pausing the video. Now 1 by 7 and 2 by 7. We are very familiar with the value of 1 by 7 because we know the value of 22 by 7, it is 3.142857 bar. Is it not? Now, if you go for taking, this can be written as 3 plus 0.142857 bar. The reason is, see the 7 3s are 21 and remaining 1 by 7. So this is the value of 1 by 7. So 1 by, we know that 1 by 7 is equal to 0.142857 bar. If you do not know, you can go for actual division. Then 2 by 7. What is the value of 2 by 7? You can write like this. 2 into 1 by 7. What is 1 by 7? 2 into 1 by 7 is 0.142857 bar. It's equal. Now just go for multiplying 2 7s are 14. Carry 1. Then 2 5s are 10. 10 plus 1, 11. See. Now if you go on multiplying like that, you will get 0.285714 bar. This is easy way of finding. If it is 3 by 7, multiply by 3. Then 4 by 7, multiply by 4. Will be easier. Now, between these two, we have to write some irrational numbers. How many? 3 irrationals should be written. Here, 0.142857 bar and 0.285714. These are the two values. Between these, we have to write non-terminating, non-recurring. I'll go for writing one by one. See, 1, 4, 2. If you may go for taking just one digit only. If you take one digit, then it will be 0.1. 2 digits, 0.14, 14. See, here also you can take 2 digits, 28, 40, 28. Between them, many are there. Can we take 15? Yes. 7, 16, 17, 18, 19, 20, 21 and so on up to 27 can be taken. 0.1, I take 1, 7, 0, 1, 7, 00, 1, 7, 000 and so on. You may take 0.180, 1800, 18000 and so on. 0.190, 190 and see that 14, more than 14, less than 28. Here 19 I have taken, 190, 1900, 1900 and so on. Clear? Now, so these are the three rationals between these two. These are the three three irrationals between these two, and these three are irrationals between 2 and 3. Now, we will move on to the next part. In the next part, actually we have exercise problems. That is exercise number 1.3. Now let us go for solving it. Before that, you just copy from here to there. Quickly pause the video and copy up to here. Okay, dear students, observe here. Here we are going to solve exercise problems. Exercise 1.3. The very first question is, write the following in decimal form and say what kind of decimal expansion each has. So here we have taken some of the problems, some of the examples. The very first one is 36 by 100. Now first let us understand the heading what has been given. Write the given numbers in the decimal form. So as in the first problem, the denominator term is 100, it is very easier. You can write 36 by 100 as 0.36, right? Then say what kind of decimal expansion each has. We have already come to know three types of decimal expansions. The very first one is terminating, second one is non-terminating recurring, third one is non-terminating non-recurring. Now you just observe this. 0.36 is there. In the decimal part, how many digits are there? Yes, you are right. 2 digits are there. That means countable number of digits. If it has countable number of digits, what type of decimal expansion? Yes, your answer is right. It is terminating decimal expansion. Now all right. It is terminating decimal expansion. And observe remaining 1 by 11 is there. Here 4 1 by 8. It is a mixed fraction. You can convert this into improper. Then you can go for solving. R is 4 plus 1 by 8. Then it is 3 by 13. You can go for dividing 3 by 13. You will get the value. So first one I have shown how to do this, and remaining 3 you just go for trying this. So before concluding the class, let me give you one information that whatever the syllabus we are covering, please work out on the same day itself. Don't keep anything pending. And another information is, today what concepts we have learned so far, all are very important. That is expressing the decimal number in the form of P by Q. The decimal number may be terminating or non-terminating recurring. Second important thing is, we have also come to know what is the condition for these decimal numbers, terminating or non-terminating recurring. And third important point is finding the number of irrational numbers between two rational numbers. Okay, so with this let us stop. Thank you.